All right, so here we have target 3 of Unit 2, slopes of parallel lines. So our first block here, parallel lines are parallel if they have the same slope. The slope must be the exact. That means the fraction and the sign. So let's talk about slope real quick. Slope is a direction. We call it rise over run. So if I have two lines that go in the same direction, for instance, this red line here could have a slope of a positive. That's a positive slope because it goes up to the right. This would be a negative slope because it goes down to the right. And this would be a zero slope because it goes left to right. That's just like what we walk across on the ground. We want grounds to be flat. And then we have an undefined slope that goes straight down, like falling off of a cliff when it goes to the edge of a building. So if we do say these two lines here, this red and blue line, have the same slope, it's kind of saying they go in the same direction. So they have the same slope. Both of these could have maybe like a positive 5/3 slope. They almost look exactly, the lines pretty much do look exactly the same. They're just not touching. Now, real quick, the next block we have are perpendicular lines. These are two lines that cross, and their slopes will have a special relationship. Some people call it negative reciprocal. I like to say opposite reciprocal, meaning they have to be the opposite sign. So I say opposite reciprocal. Okay, and when perpendicular lines cross, which this is the symbol for perpendicular, and you've seen that before, they make a 90-degree angle. So in this section and the rest of the sections that follow Target 3 in Unit 2, we're going to talk about the relationships between two lines. So our relationships are going to be, they have the same slope and they are parallel. Then we'll have lines that cross. And if these lines cross and their slopes are opposite reciprocal, then we can say they're perpendicular and intersect to make a 90-degree angle. So we're going to say, by looking at slope, the slope is what tells us. They are going to be parallel, which is option 1. They're going to be perpendicular, which is option 2. Or they're simply just going to be two lines that intersect. And there's nothing special about the intersection of the lines. So that we call a neither. So we're going to be looking at slopes and saying parallel, perpendicular, or neither. So let's look at some slopes here in our next block, and let's do some opposite reciprocals or negative reciprocals. Opposite means that the slopes have to be opposite signs. One must be positive and one must be negative. Reciprocal means to do a little flip. So the top becomes to the bottom and the bottom comes to the top. So let's look at our options here on 1 through 5. 3/4. An opposite reciprocal must look like this and must be, since 3/4 is positive, we have a negative, and then we flip the fraction, -4/3. These two slopes would create a perpendicular picture. You would see that they cross and they make a 90-degree angle. All right, so +2, remember our slopes can be a fraction, and usually we like to keep them a fraction of 2/1 because we like slope to be rise over run. So how do I opposite reciprocal the 2 over 1? Since it's originally positive, now I make it negative. And I flip the fraction to make 1/2. So there's your opposite reciprocal of that one. What do we do if we're presented with this in number 3? Negative. It's already negative. So we just got to say, let's make it opposite. So our opposite reciprocal will be positive. And we got to flip the fraction. So it's going to be a positive 8/7. So you have to do both things. You have to change the sign and you have to flip the fraction. You have to do both. That's an and. You have to change the sign and flip the fraction. You have to do both. So let's look at 1. This is kind of a weird number. So 1, we can just say it's 1 over 1. This is going to look a little weird, but 1 over 1, opposite, change the sign, becomes negative, and 1 over 1, when we flip it, the reciprocal, it just becomes 1 over 1 again. So 1 and negative 1 are going to be opposite reciprocals. Now, I briefly talked about a zero slope here. A zero slope will go straight across. That's what we like to walk across in our buildings, a flat surface. What's opposite reciprocal to that would be this. So if the zero's on top, I make it a fraction. And then I'm looking for an undefined line that's going to be perpendicular to that. So that means when these things cross, we're going to make a 90-degree angle of straight across and up and down. So what is opposite reciprocal or perpendicular to 0 over 1 is our undefined line. So that's undefined. That's what the slope looks like when we go straight down. All right, so there is some examples of opposite reciprocal. Remember, parallel lines have to have the same slopes. The slopes will be exactly the same, and perpendicular will be opposite reciprocal. If it's neither one of these, we just say neither. There's lines that cross, and there's nothing really special about the intersection. Now, before we go on, a brief review of slope. If you are given a graph, we don't want to use the graph formula. It takes too much time. We can easily do it if we simply do rise over run. If we do rise over run on a graph, it's much, much quicker. So let's talk about our process for doing this. We're going to start at the leftmost point. A is our leftmost point, and then we're going to go to the right. So here is my starting position. This is how we do slope. And you've done it before, but I'm just going to give you a review. So slope is directions. If I start at A, give me the directions to B, my destination. So let's look at A. We always do the top first. So that means you're going to go up or down first. And so we're going to rise. So let's get to our level playing field with B. So now I've risen to be level with B. So my rise was 1, 2, 3, 4. And that is going to be the top of my fraction. Then I'm going to run and stop at my final destination. And I'm going to count how many I run. 1, 2, 3, 4, 5. I am at my destination. I have given you correct directions on how to get from A, my left point, to B, my right point. Now, if we're given slope as points, it's a little more complicated because we have to do a formula. And I'm sure all of you have seen this formula several times and maybe even have nightmares about it. But my formula is going to be y minus y over x minus x. And this is a little different from traditional textbooks because they like to put a 2 here and a 1 here and a 2 here and a 1 here. But all I'm going to do is I'm just going to start left to right. So I look at my first xy, and I'm going to start with a big division symbol. So what I did was I put my fraction bar in and my 2 minus symbols. So now all I'm going to do is take that first y and put it in my first position up top. and its buddy, its partner in that set of parentheses, the -2, the x, I'm going to put it below it. Now I'm going to do the exact same thing. I'm going to take my second y and I'm going to put it in a second position on top. And here I'm catching that double negative. So now I'm going to see, I'm going to have to add these now. And I'm going to take that first x, I'm going to put it underneath in its position. Now I'm going to do top, 5 plus 1. I'm going to do bottom, -2 minus 6. And I can use my calculator to reduce it. It stays negative. And then I'm going to have 6/8 reduces to 3/4. That is the slope we always want to reduce. That's how we compare our slopes, is in reduced form. All right, so now we're going to look at these three options, and we are going to say use the slope to determine if lines A, B, and C, D are parallel, perpendicular, neither. So back to my picture here, this is our test. We have three options, not 4, not 5, but only 3. They have the same slope. That would be here. It's parallel. They have opposite reciprocal slopes. Then they're perpendicular. If it fails for both of these, if it's neither one of these, we go ahead and say neither, our third and final option. So the multiple choice options here are just going to be out of 3, A, B, C. A lot easier than 4 or 5 options. So what it says is look at A, B, and that's a line. So I'm going to put a little divider here because A and B are on a line and C and D are on a different line. And all I'm going to do is my y minus y over x minus x, and I'm going to do it for both and then compare. I'm going to put slope 1 here, slope 2 here, and then make my decision based on the criteria for parallel, perpendicular, and if it's neither, we do write neither. All right, so I'm going to put my big division symbol here. I put the fraction bar and my 2 minus signs. I'm going to put my first y and my first x underneath it. I'm going to say my second y and my second x underneath it. I'm going to do the math, 3 minus 6 on top. If I'm going too fast, remember this is a video, you can pause and rewind. -2 minus -2 is -4. Remember, a negative over a negative cancels out, so this slope is positive 3/4. On to the next one. I'm going fast to make this video shorter. My first y, my first x. My second y, my second x. I got 0 minus 3 on top, -1 minus 3 on bottom. These cancel out. Now I look at my criteria, parallel. Parallel slopes are the same. These are the same. Therefore, these are parallel. It's my first option. Okay, moving on to make this video shorter. Doing the same thing here. I'm going to do my division, my big division sign to make life a little easier in my opinion. First y, first x. Second y, second x. 2 minus 4, 0 minus 5. These cancel out. Slope of 2/5. If I go fast, please pause and rewind. Okay, here's my big division sign for this one. First y, first x, first y, or second y and second x. 8 minus 3 is 5. 1 minus 3 is -2. We're not going to make it a mixed number. We're going to keep it a rise over run, so it's -5/2. Let's look, parallel. They have to be the same. That's not going to work. They're not exactly the same. Now, let's check perpendicular. They have to be both opposite and reciprocal. This is positive, this is negative. Our first our first part of the criteria is good. They have to be opposite and reciprocal. So now we have to test reciprocal. Did the fractions flip? Yes. 5 went to the top, 2 went to the bottom. This is an example of perpendicular. All right, what I'd like you to do now is pause the video and try to see if you can do number 3, because in 5 seconds, I'm going to start number 3. All right, so hopefully you paused and tried it. Here is my first slope. All right, so these are some bigger numbers. Our first y and its partner underneath. Second y, its partner underneath. I catch the double negative there. Negative 12 minus 2 is negative 14. Negative 9 plus 2 is negative 7. This reduces to positive 2 over 1. I like to keep slope of fraction rise over 1 because I can easily see something flip if they're fractions. So those flip, that's a reciprocal. All right, last one here. So I got my big symbols, or my big division sign. First y, its partner. Second y, its partner. Got a lot, both top and bottom have double negative. 6 plus 2 is 8. Negative 1 plus 5 is 4. This reduces to 2 over 1. 2 over 1. Let's see what you think. Parallel, perpendicular, or neither. They are the same. These are parallel. All right, so there is target 3 of our second chapter.